Hello world, I'm Isla Baker and we are live here in the lab.
The lab, choo.
Today we have a special guest on the other line, Ft.Jack Cuila. Now Jack, welcome to the lab. Tell me, what are we going to be looking at today?
Plastic. I'm pretty sure you've heard this word before.
Of course, the base to all of our bags, our packaging, our...
Green eradication. PVC. Polyethylene. Ethylene. Propylene. Butane. Polystyrene. These are hundreds of types of plastics that are around this world.
Plastic is considered bad for the environment. Why is this?
Because animals, birds, turtles, constantly mistake it for food and eat it. The chemicals inside of it poison them, and they believe that they are full, causing them to die of poisoning and hunger.
Oh yes, of course, I was reading up on this. Is it true that not only does it make our animals race to extinction, but it makes us eat the poison from which they died?
Which can cause anything from brain damage to cancer? Yes, this is very true and overlooked in our world.
But we have grown so dependent on this material. How are we ever supposed to fix the damages caused, and how are we supposed to prevent it from causing damage in the future?
Plastic is just one type of material.
Interesting. So why is the material so hard to get rid of?
It's non-biodegradable.
Non-biodegradable? Well then, what is biodegradable?
For something to be biodegradable, it must be made of natural materials.
Jack Cuila's stunt double, Scott Baker.
Okay, but what's the difference between that and something that's non-biodegradable?
When something is non-biodegradable, it lasts forever. After many years, non-biodegradable plastics break down into tiny pieces called microplastics. But if it's made out of a natural material, it will break down over time like a banana peel.
Well, is it even possible to make plastic with natural materials?
That's just what I decided to look at.
Well, my watchers know how the lab goes. How about you walk us through yours?
Well, I wanted to see how vinegar and starch bioplastics with different levels of vinegar would compare to the capabilities of a Ziploc plastic bag.
So basically you wanted to make a vinegar and starch bioplastic and test it against a Ziploc bag to see which one will work better.
I hypothesized that the plastic with less vinegar would be stronger because it would had the thickest batter.
So you hypothesized that because it had a thicker batter, it would end up having a more dense plastic and therefore be stronger.
I'm going to change the amount of vinegar that I'm adding to the plastic. The things I'm going to keep the same are the amount of glycerin, the amount of water, the amount of cornstarch, and the way it is being made. Once I have the plastic made, I'm going to measure its strength and effect of water on the plastic. Then I will take the plastic and put it through many different tests, including the weight test, where we weigh the plastic, the water test. This is basically a weight test, but we put the plastic in water for 5 minutes, and then we test to see how much it can hold. And the results were quite shocking. Take a look, Isla.
Well, it looks to me like you found out that the plastic that has the most vinegar will hold the most amount of weight. Now, it's very possible that there were some inconsistencies in this data. There were a lot of times in which some measurements in the plastics got a little jumbled up. So plastic number 3, which was supposed to have the most vinegar, could have possibly had too much or too little vinegar inside of it. So we're not 100% sure. So that could be a limitation or a reason for a change in the graph.
I took the liberty to make this data into graphs, and if we take a look, we can see that the plastics were much stronger before the water, and after which they performed very poorly, without a single one of them being able to hold even 50 grams. Before the water, however, the plastics had quite impressive strengths, with plastic number 3 only about 85 grams away from holding the same amount of weight as the Ziploc. It's not surprising to me that the plastic was not water resistant, as many sources state that the common starch bioplastics are not waterproof unless there has been some sort of crude oil used, making it debatably non-biodegradable. Thank you guys so much for coming to the lab today, and thank you to Jack Cuila for joining us and telling us all about his bioplastic adventures. I really hope that you'll join us next time. Don't forget to subscribe. Alright!